All right, Yuri, we're home, man. Well, you're home, came home with me. So we're gonna start doing some videos from home now. Try to do my best, kind of right during the virus scare here. So everybody's sent home. Gonna reorder the videos a little bit, but we'll do our best, me and Yuri, try to figure out how to get through all the material for you and go through this stuff as good as possible. You still took a screenshot of that thing, right? So what we've got here is chemical and physical weathering. Let's go over that for a little bit. We've got the line down the middle here. There's chemical weathering. Chemical weathering is anytime you're making new stuff. So oxidation, that's rusting. A lot of rocks have iron as a component of them. Iron can get rusted and break rocks down. And then dissolving. Water does a lot of that dissolving. So we'll do a few practice questions with just to show like caves and stuff like that. That comes up a lot on the test, and it's pretty straightforward. Here we have one of the types of diagrams they like to show for chemical weathering. So you've got hydrolysis. It's caves. Anything to do with caves, stalactites, stalagmites, dissolving. Limestone is the #1 thing that shows up with this a lot. If you're seeing anything with caves, this diagram, chemical weathering, okay? So the question's asked a ton. And if you're looking at these four down here, obviously A or B could be the answer. C or D is not. Chemical weathering and runoff, chemical weathering and groundwater flow. So they throw that little tweak in there. This is a groundwater thing. Runoff, you've got to remember, is at the surface of the earth. Groundwater is when the ground that is holding the water, and in this case, it's dissolving the rocks. Another diagram with caves. I guess my pictures kind of didn't all show up here, but you can see that they're going to show limestone, they're going to show dissolving. Sometimes they'll also show some sinkholes. If a cave can't support itself and it sinks into the ground, that's another piece of evidence for chemical weathering. So the two answers that you would go for, the actual answer, it looks like it would be D, it'd be chemical weathering of limestone, which you can't really see right there. No big deal. Here you're going to show an increase in chemical weathering between the two. The powdered limestone is going to have more chemical weathering because when surface area goes up, chemical weathering goes up. Here's another example of the process of weathering. Sometimes they'll just be straightforward and ask which process is happening. You're taking feldspar, which is a mineral that you can remember. If you're adding water to it, that's dissolving or breaking down the minerals into new things, so chemical weathering. For physical weathering, it's a little harder to show you some examples. We'll kind of come back to this stuff as we go through the different modes of erosion. So what you have there is, for the physical weathering, surface area. More surface area makes more physical weathering happen, and it's just breaking down the rocks into smaller stuff. In our climate, New York State, frost wedging is a huge contributor to breaking down rocks. The water gets in the cracks of the rocks, it freezes and thaws and freezes and thaws and expands and contracts and breaks them apart. And then exfoliation is another one. When you take weight off of rocks, they'll start to break apart a little bit from less pressure. All right, so those were the questions. Just to look at this one more time, make sure that you're just understanding breaking down into new stuff, breaking down into smaller stuff. Smaller stuff, once this happens, this will help this to happen, because if you make smaller pieces, chemical weathering can kind of dissolve things faster. Same thing when you're, I don't know, eating a lollipop. If you chew it up, it'll dissolve quicker.